I don't know about you, but in my personal game project, I've ended up with a mess of managers all trying to handle different aspects of the game. They have roles ranging from controlling procedural generation, handling item databases and crafting, monitoring NPCs, storing references to sound effects, and a whole lot more. This has led to a somewhat cluttered and hard to navigate hierarchy. Much of the actual game data is also stored in scriptable objects. Scriptable objects are used for spaceship module data, item data, crafting recipes, and even colors for the UI. This leads to project folders that, while structured, can once again feel cluttered and hard to navigate. Now, I don't claim that my method is the best, but I suspect that it's a fairly common approach. So I thought there has to be a better way to manage all these scripts and all this data. And there is. Probably several ways. The method I chose to explore was to create a custom editor window using the built-in tools that come with Odin. The result? Not just another game manager, but rather the game manager. Now you may ask, what's the advantage of doing it this way? Well, by and large, creating an editor window with Odin is easy, especially when compared to building a window with Unity's built-in tools. All we need to do is create the window itself, add a few buttons, and then we can make use of the inspectors that are already in existence for each type of content that needs to be displayed. The majority of the drawing will be handled by Odin attributes that aren't part of the editor window, but are part of the classes being drawn. This is an important and stark difference between trying to create your own custom windows from scratch. This project is also a reinforcement of two ideas we love with Odin, that is building through composition and ease of maintenance and expansion. Creating this editor window will span 3 videos. This video will focus on building the window itself, and subsequent videos will look at adding content to the window in such a way that further content can be quickly added as the project develops. If you haven't watched our earlier videos on creating an editor window, as we may gloss over some of the details that we covered in other videos. This video is also more focused on what can be created and less so as a follow-along tutorial. Every editor window is going to be highly dependent on the project, but we hope this video series can show you the framework and some good practices when building an editor window for your project. Despite this editor being specific to my personal project, we will include the code for the window in a GitHub repository to make it easier to review. The code won't be functional as it will have project-specific dependencies, but hopefully it's still helpful to you. So let's jump into it. The vision here is to create a set of toggle buttons at the top of the window that will allow us to control what is displayed in the window. In some cases, this will just be a simple class that is displayed, and in other cases, we'll add buttons or even make use of the Odin menu trees to help manage scriptable objects. To create our window, we need a new class. Since this will make use of editor functions, it's best to place the script in an editor folder to avoid future errors. With the file open, we need to add several namespaces as well as change what the script inherits from to Odin Menu Editor Window. The class Odin Menu Editor Window requires the implementation of the function buildMenuTree, but otherwise is nearly identical to Odin Editor Window, which itself inherits from Unity's Editor Window, but with additional functionality. Before we get to the menu tree, there are a few other things we need to do first. We need a way to open the window while inside Unity. We can do that with a static function and using the command getWindow, giving it the type of window, followed by the function show. We can then add a menu shortcut with the attribute menuItem, and then provide a name for which menu in Unity it should appear under, and then the text or name that will appear in that menu. In my case, we're going to add the Game Manager to the Tools menu. If we give it a quick test, we can open the window, but we'll get a stream of errors. So let's first fix up the menu tree. We're not ready to populate the menu tree yet, but we can still clean up the errors. We can do that by giving the function buildMenuTree something to return, and to do that, we can create a new instance of an Odin menu tree and return that value, like so. This won't do much, but it will create and display a blank menu tree, which will prevent the stream of errors. Next, I want to create the toggles at the top of the window that will provide navigation for the editor window. Now this could be done with a button group, but that would require a function to be called perButton. So instead, I'm going to use an enum and the attribute enum toggle buttons. The values of the enum are of course 100% dependent on the project. So if you're trying to follow along, create yours as needed for your project. On the enum field, I'll also add a few more attributes to provide a little more formatting in our editor window. In some cases, I want the menu tree to show, in others, I don't. In both cases, it would be nice to have the enum buttons at the top of the window so they move around as little as possible. To do this, we need to work around some of the built-in intentions of Odin editor windows. As what we're doing is pretty custom, control where the enum toggle buttons show up, and if and when the menu tree shows up, we're going to need to override a handful of functions and customize how they are implemented. All of these functions are called automatically by Unity or Odin. So for now, we need to make sure each one still calls its base function to maintain full functionality of our editor window. Let's start at the bottom of our list of functions and walk through what the functions do or control and build up the basic code of each. The function drawMenu will control when the Odin menu tree is drawn, which means we can use a switch statement and the enum to simply call base.drawMenu when we want the menu tree shown, and not call it when we don't. For my project, I have a handful of cases where I want the menu to be drawn, and I need to call the same function in each case, so I can let the switch statement fall through to the last case, like so. Next is the getTargets function. Here we can create a list of objects for the editor window to draw. This will give us more fine control of what gets drawn, and we'll come back to this function later to add more targets, but for now, we'll just create the list and add a single target. That target is the base function getTarget, which consists of properties and fields in this class, or more specifically in this case, it's the enum toggle buttons. If we let Unity compile, we can see that as we change the value of the enum, the menu tree toggles on and off, but our enum is still not always on top, so let's fix that. To do that, we'll need to build up both the onGUI and drawEditors functions. onGUI gets called before the other functions, or more specifically, the other functions are called from inside onGUI. For this reason, we need to make sure that we continue to call base.onGUI, or we'll essentially lose all the Odin goodness and just be back to a regular Unity editor window. This means we can draw the enum toggle buttons in onGUI, and it will get drawn before the menu tree. To do that, we need to call drawEditor and give it an index of which target to draw. In our case, that index is 0, as there is currently only one target in the list. But this is where we hit a snag. GetTargets is called in base.onGUI, so the targets are not defined, and we'll get an index out of range error from our drawEditor call. There are a few solutions to this, such as a boolean that prevents any drawEditor calls happening the first time through the onGUI function. In my case, the default value of the enum does not show a menu tree, so I can avoid the error by only calling drawEditor for the cases that need it to be done in onGUI, and the rest of the cases will call drawEditor inside the function drawEditors just below. Do note that I'm not allowing the switch statement in drawEditors to fall through, as I'll be adding more code per case in a later video. At this point, we can let Unity compile again, and we can see that no matter the enum value, our enum toggle buttons stay at the top of the window. And yeah, it took a chunk of work, but in my opinion, it makes the window easier to use. While I'm at it, I'm going to add a nice title and a little spacing in the onGUI function to make the formatting a bit better. In the next video, we're going to start adding more targets that will get drawn based on the enum value. Since drawEditor takes in an integer, with a little care, we can have our targets correlate to the enum value, and this will make our code easier to read and easier to add to. This also means that our target of base.getTarget should be the last target in the list, and its index will change as we add targets. So let's do a little workaround and create a new variable that tracks the number of targets, or rather it will track the index of the enum toggle buttons. This can be done by subtracting 1 from the count of the targets list at the end of the getTargets function. We can then change the index in our drawEditor commands to the value of this new variable. Now at this point, our editor window isn't very functional, but the framework is in place to start adding more content to the window. In the next video, we'll look at creating a reusable generic class that can be drawn for all cases that will make use of an Odin menu tree. And all of these cases will handle a different category of scriptable objects that hold some game data. We'll also be adding functionality to our window to create, delete, as well as edit instances of the scriptable objects. So we hope that was interesting and better yet useful for your project. And until next time, happy game designing.